Okay. Hello. It's 9 o'clock in Germany. It's maybe a little bit later in APAC region. Hello, and thanks for joining our webcast. Today, webcast is about BeeGFS version 8 specific features. It's about the parallel copy tool. I have also invited my colleague Federico. He is responsible for this tool in our dev department. And we want to show together how to use this tool, how easy it is to create an environment where you can use a parallel copy tool without any scripting or difficult setups. And yeah, we are just in time, so let's start from here. You have always the chance to ask questions in our chat function, and we have on the end also a Q&A session. So if you have specific questions to parallel copy tool, then let us know, and we want to discuss and give answers as much as possible at the end of the session. This session is recorded for further use on our website. So if you don't like to have this, then please switch off. Okay, let's start from here. BeeGFS, the easy data management for everyone. As you all know, we have released the BeeGFS 8 version the beginning of this year. And in the meantime, we have the 8.2 release, actually 8.2.2 is the complete number that we have. And with this new version 8, we had a lot of new data management functionalities included in this software, especially over an API. So that means we don't touch the core of the file system that much. We have more built an API around this so that third-party applications or our own tools can use this API to have access to the file system and file system information. Today we want to talk about the copy tool that we have included. It is part of the BeeGFS 8 enterprise version, and it comes with the software. BeeGFS Copy is one of the tools that we have announced with version 8. So that's not a standalone product. It can be combined with other features that we have included in version 8, like the index, the pools, and also the remote storage targets that we had a webcast 1 month ago already about it. And in this combination, we can create a very powerful ecosystem where you can manage data, move data from a repository to a Scratch file system and in other direction. You can also move data into a cloud or a deep archive kind of thing. All these works together. All these are very simple to use so that we try to make it as much as possible easy to use and also not being complicated, not depending on third-party tools, so that we really can go directly with a BeeGFS native function that you can use here. About the BeeGFS parallel copy tool, it is part of the BeeGFS Hive Enterprise version. That means if you have an enterprise license for your environment, you have also access to this copy tool. It's important to understand that you need a license on a management server for this, otherwise the tool wouldn't work. And it's included in your contract already. If you have a BeeGFS 7 installation and you want to update to version 8, you can do this without any additional costs, and you will get also access to these tools like copy, watch, index, remote storage targets. All these things are included, and there is no additional license fee if you upgrade from 7 to 8 in this area. What exactly is the BeeGFS copy tool and why should we use it? The parallel copy tool is included, as we mentioned, it's part of our CLI that we have for BeeGFS 8, and it gives you the possibility to have a single command line tool that can move a large amount of data between two POSIX file systems. You can use this for migration purpose, you can use this for loading and offloading data to a Scratch file system, from whatever POSIX file system you have. So that it's a tool that's also working between BeeGFS and other POSIX file systems. So you can combine it with a Lustre, with an NFS, whatever you have installed in your data center. And the main goal was to utilize multiple clients at the same time to move data from one POSIX file system to another one. If you imagine you have two file systems, one is a repository, one is your Scratch file system on your HPC environment, then you can utilize these clients that have both systems mounted, and you can utilize them with BeeGFS Copy to move the data between these file systems. What BeeGFS Copy is doing is it automatically split a bigger copy job into multiple threads, and also large files can be cut into chunks and used in multiple threads to copy data between. And we will show later in a short demo environment how much this can speed up the process to load data, because you don't need to rely on rsync or other single thread copy tools. You can use this, that's included, and you don't have any dependencies to MPI or other third-party tools to distribute the job over several nodes. And I mean, this is one of the practical, I would say, benefits that you have with the copy tool. It doesn't need any third-party tools for being, I would say, active. If you install BeeGFS and install the BeeGFS RPM package, then you can use it, and that's it already. What you need to use it is to install the BeeGFS copy package. You need a client that has both source and target mounted at the same directory. So that means the clients that using these tools must have both POSIX file systems mounted on the same directory, because we're using all the same paths in this copy scenario. And we need a passwordless SSH connection between the nodes that doing the job and the node that is running the BeeGFS copy command itself. But otherwise, other than this, there is no dependency for other third-party tools on this. What would be the use case for BeeGFS, or where we see the benefit for this? That's for first, it's a BeeGFS to BeeGFS asynchronous copy of project data between a Scratch file system and a central repository, for example, where you say you want to load data into your Scratch file system, doing your calculation, and then offloading the results back to a central repository. But this can also run between different file systems, so BeeGFS to Lustre or Weka or GBFS or whatever can be done. And it's also an idea to use BeeGFS together with Beyond if you have dynamically created BeeGFS on demand file system for Scratch on your HPC cluster, on your compute nodes. Then the parallel copy tool would be the ideal thing to move data to these Beyond environment, so to shrink the time that you need to load the data into your file system, and also to leverage your HPC cluster better, then you can shrink the time that it needs to start a job. You see here the simple command, how easy it is. BeeGFS is our CLI tool that comes with BeeGFS version 8. So it's part, the BeeGFS copy tool is part of the BeeGFS CLI. And then it's the command copy. And then you give with the -m a machine file or a list of servers that you want to use for this. These servers are the servers where you have installed your BeeGFS copy package. And if there is a list with 2 or 4 or 10 or whatever clients, this must be an ASCII file only with the host names that should be used here. Then we have the -t that gives the opportunity to set a number of threads that you want to have per node, per data mover that you use. This can be up to the number of CPU cores that this server has available. So, but this is something you have to play around a little bit in your own environment to utilize. these nodes as much as possible, or to shrink the performance, or to get some kind of quality of service. How much performance should these servers provide here? And then, like you can know it from a copy tool, you give the source and the target here. And important, you can have multiple sources, and all this will be go in the target directory. In this case, mount storage B destination, and there you will see subdirectories for all the sources that you create here. And last but not least, and very important also here for some kind of disaster recovery scenario where you want to do an asynchronous copy of your stretch data, for example, you can also run an update command here. That means with this command, the system will check if there are new files or with changed timestamps, and then they will only copy the data that has changed. So if you want to secure, for example, some files from your HPC environment, if you have a checkpoint, for example, if the system writes some checkpoints, you can run this script on a regular basis for 10 minutes or 20 minutes or whatever, and then the system will copy these data to a central repository to be sure that you don't lose any important data from your Scratch file system here. How it works in the past, or most of our customers using copy or async in a way that they move data from their repository to a Scratch file system or vice versa. And then you can see here, if you have only this single command, you have only one data stream, and this is the limit here. If you want to speed up this process, you have to script something where you use multiple copy commands in parallel to get more performance from these servers, because otherwise you are bound to this single thread, and this will limit you in the utilization of the bandwidth and also on the performance itself. With BeeGFS Copy, you have this command where you can say, I want to have multiple nodes in this tool. I want to have multiple threads on these nodes. In our case, we have 5 nodes, and then we starting this with 4 threads per node, and this will give you 20 parallel threads. And the system, and you will see this later in a demo, it's really scaling linear. So the more server you put in, the more threads you put on these servers, as long as they can utilize the bandwidth of the storage, you will see an increase on the performance that really gives you better results and a shorter time to load and offload data from the system itself. Here's a short explanation and a short overview of how fast this can be. You can see here the blue colored line. That is a single CP, as we all know, and you see also the number of files that you want to transfer, and the time that it needs to transfer these files. And as you can see there, if you do parallel copy with 1 or 2 threads, you see that the system will already take less time for doing these commands. And if you use it with 2 nodes and 4 threads, you will see that it shrink the time for this from something around 160 seconds, less than 20 seconds. And this is already a large improvement in doing this. And now I want to hand over the screen to Federico for a short demo. We have prepared only something in our lab, so it's not a very large environment, but you can see there how this works and how easy it is to use it.
Hello, everybody. And now I'm going to share my screen. Okay. Okay. This is just a very small environment. Before, let's say, sharing my screen, I ran with CP just to give you, let's say, idea how much time needs CP to copy this folder. This folder has 100 files, 1 gigabyte per file. So it's really 100 files, 1 gigabyte each, and it took almost 3 minutes. While if we now I remove the destination folder that it has been created here in source, so in destination. So I remove this, and now I use the tool BeeGFS Copy -m node. This is only one node just to start. I mean, this is a very small environment. Anyway, now we can definitely see the boost in performance, BeeGFS source, and we copy this inside BeeGFS BeeGFS destination, and we want to have some statistics just to, and maybe I just put also the highest verbose mode just to see the info that the tool could provide while it's running. So now it's copying. I mean, there are some messages that should appear soon, but for caching, they are kind of grouped here, you see. So it recommends to not modify the directories while you copy the data. It starts the parallel environment. And here you can see that which thread is taking care of which file. And then in this case, it took 25 seconds, you see, to copy all the data instead of almost 3 minutes that it took CP. Obviously, if we remove some verbose mode and everything, I mean, it takes, okay, let's remove the data I copied, and I can rerun it without the verbose mode. It takes slightly less time. Now, I mean, this setup is very small. It has like 5 or 6 NVMEs. So basically, we are already reaching the bottleneck of the underlying, let's say, hardware environment. It should take now, yeah, again, maybe 22 seconds, something like this. If and I'm already using only one node and 4 threads. Yeah, okay, 25 seconds. Oh, let's say verbose mode has not a very relevant impact on performance. I can increase the number of threads. Maybe now, I mean, it will go down to 20 seconds. So anyway, it's almost 9 times faster than CP. But again, I'm really reaching the bottleneck because you can see it has like, yeah, okay, 70 seconds with, let's say, 6 GB per second of copying of data. But yeah, I can show you this setup. It has 7 NVMEs, but are pretty old NVMEs. So it total is like 14 GB for writing and for reading. And we are already using kind of 12 GB because in this copy operation, there is both read and write. And so you see that it really, in such a small scenario, you gain almost 1 order of magnitude in copy performance. Now I can also show you the update feature. So now let's update this. I put -u and also the maximum verbose mode. And now these two directories, the source one and the one created by the copy tool, are compared. And in case any difference is detected, the file, the difference are updated. So now it copies, it checks all the elements. Again, this is verbose mode, usually don't have, and it says, okay, no difference because we just copied it. Now I'm going to remove just a file from the target path. So BeeGFS destination source, I can remove one file and run it once again. And now you see here, list of paths to be created, updated is this one. And this has been copied and the job has been done. Since I still have, let's say, 1 or 2 minutes, I just want to show you maybe the options, because there are some additional options. In particular, for update, there are some options for the access or for the modification time if you want to, let's say, to preserve that in no, sorry, these are also for the copy. If you want to preserve access time or modification time in the copy, or you can also specify different, let's say, different condition on the modification time for the update, and or you can also specify the partition threshold, because I mean, here when I copied, you see that basically one thread take care of a single file, because this file are almost 1 gigabyte, like 999 megabyte, and so they are below the default partition threshold. But one can also, let's say, decrease or increase according to the file he has to move the partition threshold to trigger the split of files in chunks at a different level. And the last thing I wanted to mention is no, okay. I think that's basically all. These are the features, the options, let's say, and yeah. You can also specify additional input. So, for example, now I'm going to remove the all the target directory. Yes, and then I want to copy, let's say, only some files. Okay, for example, I can say file 001, mount BeeGFS source file 012, and only these two files will be copied. Okay, I didn't put any, let's say, any verbose flag, so this is the default. Yeah, there is only this warning to not modify the directory trees during the copy process to avoid inconsistent copy of the data. And I think this is, let's say, it's all I wanted to show you. If you have any questions, or if you have any, let's say, additional curiosity, please just ask. Or if you want to see some additional, let's say, show or demo, just please ask.
Maybe one question from my side, Federico.
Sure.
There's also a possibility to use a text file or a standard input for using the copy tool. So that means you can also create a list of files and hand over this list of files to the copy tool to move the data. So if you prepare your job, for example, you want to move files from different directories, and you have with your Slurm environment already a list of raw data that you need for your copy job, then you can hand over this list of files to the tool, and the tool will use this as an input for moving the data to the destination.
Yep.
That's the parameter with the standard in, right?
Yes. Yes, yeah, there is also, yeah.
Okay. I think this could be very helpful if you have a file list for your job already. Then you can hand over this list to the tool, and the tool will move exact these files from different directories if needed, and move it to one destination, so that you can run your job there without collecting all the data upfront or starting multiple copy jobs in parallel. You can do this in one step, and it just makes life easier. And life easier, that's already our point. We have our Q&A session now. I have no questions here because I think the tool is very easy to use. There is not that much questions around it. And it also shows how easy it can be to move a large amount of data without installing MPI or other tools on this. The copy tool itself has its own distribution, I would say, mechanism that comes with the tool itself. It uses an standard API for this, so don't need to have an install of an MPI environment or something like this. And from there, if there are no other questions, I would say that was already our
I just
session.
want to add one in this let's say environment, we can see like a 9-10 times boost in performance, but in larger environment we have seen up to 60-80 times faster compared to CP with a larger, let's say, parallel file system and larger setup. Just to give you, let's say, a rough idea of the boost in performance and also the time you could save using this tool compared to CP or rsync.
Yeah, I mean, important is that you can use multiple clients for doing the job in parallel, and this will speed up really compared to our small environment here in our lab. If you have multiple clients mounted on both sides, then this will really get a very boost for the performance, and this can shrink the time to start your job extreme. So that's why I think this is a good thing to have. And if you have any questions, please reach out to us, send us an email. Federico, me, we are available for this. And yeah, with this, I would say was a short session this time, but we mentioned everything. And if there is no question, I wish you a nice day and see you soon in the next session. Bye.
Bye.